Hi there, everyone. So, this is my presentation for the Biomimicry project. The plant I've chosen for this project is Salvinia molesta. It is also known as giant Salvinia. This is a plant usually found on the small lakes and ponds and other water surfaces. This is a floating aquatic plant that floats on the surface of the water body. How does it float on the surface body? That is a thing we will be looking at. So it has these small air pockets on the surface of this plant, which creates a barrier of air between the plant itself and the surface it is coming into contact with. That helps it float on the surfaces of the water bodies. Now, the surface, as you can see, there are these tiny over here. These are these tiny air pockets, the fibers, which help the plant maintain a barrier between other surfaces. The surface of the plant is covered with tinier pockets, which are shown above, like these, that create a barrier between the plant and other surfaces it comes into contact with. If I'm to zoom in here, you can see how this is a water drop. This is a water drop, how it floats on top of the surface. This is a vertical orientation of the same thing. If you talk about the uses of the plant for humans, which is biomimicry for innovation and stuff, then we could use the ideology, the application of this plant in many different factors. For example, we could create physical barriers between objects. We could create fabrics that don't mix with liquids. So, for example, waterproof bags is a really nice example of this phenomenon. We can also include safety suits, floating mechanisms, road safety barriers, for example. We could work on something which is a concept of anti-collision barriers. If a car collides with a barrier, if it is bound to have an accident, we could use suppressed air to cause a physical barrier between the car and the barriers and the road barriers, which could result in a less impactful and dangerous accident. We could design safety suits for the firefighters in such a way that the smoke particles do not enter the mask or the respiratory systems of the firefighters. There are many uses, of course. The practical application is Aircoat. Aircoat is a firm that works on painting the surfaces of many ships and marine transportation vehicles so that they float easily on the water. Uh, this results in a this results in a lower chance of sinking, uh, as it already floats. So it means that the resistance it is getting from the water is also reduced. It could reach higher speeds with low energy consumption, so it's energy efficient. And there are multiple other uses in Aircoat. So Aircoat is a firm that has studied the floating properties of Salvinia molesta or giant Salvinia to create a surface lining, a paint that not only helps in floating of marine transportation, but also reduces biofouling, fuel consumptions, and associated emissions. If you can see over here, if you zoom in over here, this is the this one's the normal, um, and this one over here is the one with the air coat. Now, if you see velocity zero, speed zero, there's a high gradient and there's a high shear stress on the surface of the boats. If you come to air layer, like we apply the air coat over here, the velocity is greater than zero. I mean, it's easier to move the way. There's a lower gradient and there also a lower shear stress, so it would move with lower with ease. If you come over here, now this is a species of aquatic species on the marine belt, which stick to the boats. If you This is like normal it's like a normal stuff. If this is this, like for example, uh, over here, this is the surface of the board, and this is the surface of the board with the air coat. Now, if you use this air coat, there is less residue on the surface. Similarly, you can also observe this over here. There is much more residue than on the surface of this surface. Now, if you move over to what the air coat does is, first thing, they took Salvinia as their biomimicry source, and then they caused this they caused this air barrier in to their surfaces, which separated the water from the foil surfaces. Then they used the adhesive, a glue or something, to stick that to the air coat, and then they air coated these ships with it, and these prove very economic efficient. Um, as you can see over here, you are using green energy without harming the environment anymore. Yeah. That's my presentation. If anybody has like any questions regarding it, I'll drop a link. I'll drop my email address with the on the video, so you can reach me out over there. Thank you so much.